So now I want to talk about the next feature, which is the multi-objective scans. Firstly, what we want to do is change the objective to a higher power objective. So we start first by clicking the objective profile on the left here. Here we changed to a 10x, but we haven't physically changed it on the microscope. So we will do that now. And then, as I mentioned before, 10x and above, you want to put your condenser up. And once you put it into focus, the thing that I want you to notice is that the box has now become blue. That means that the higher power objective is currently matching to the lower power objective map, which is the 4x that we generated earlier. So we have a number of modes here. As mentioned, we have the free mode, which lets you move around without being tethered to the camera. Follow camera is self-explanatory. As you press follow camera, the view moves with the camera. We have the pan to fit, meaning as the field of view hits the edge of the window, it starts moving. And then we have the zoom to fit, and make sure that everything we've built so far is visible on the window. While we're on the topic, we can quickly go over here. This is a scan view. It shows everything that's been scanned so far. This is again the split view. And this is the live view. It shows what the live view is currently seeing in a full screen manner. So going back to the topic, once we've managed to switch our objectives, you can find an area of interest to do your multi-objective scan. Once you found the area, click the green plus button on top. What this allows you to do is take a region of interest, on top of your 4x map. Once you're finished with your region of interest, you can do one of two things. Double click on the dark gray area, or you can click on the main 4x tab. What we're going to do here is just click on the main 4x tab, and that takes us back. So when you look on the scan view, now you have a 4x map with a higher power embedded scan that's shown in a black box, and you double click. Now you can view the entire the region of interest at 10x. This can be done with any objective that you would like. The only thing to be aware of is that sometimes, because the system works by matching feature to feature, if you have features that are too far apart, for example, if you're trying to match a feature that's at 4x to 100x, that might not work. And this will be denoted by a yellow box. And the solution to that is just to bring the magnifications a bit closer. So, for example, trying 20x to 100x, or 10x to 100x. Now, every element that we embed can be titled, color-coded, and annotated. And they're all libraried on the left here with scans. If we have 5 scans, we will have 5 items here. And they can be additionally annotated with our number of annotation tools. And as usual, you can title them, color code them, and annotate them. So that concludes the section on multi-objective scan. for the next feature, which is the Z-stack, we will demonstrate on a thicker area such as this one. So as you can see on the right here, the differing thickness causes it so that a two-dimensional scan doesn't really capture the full detail. So in order to capture a Z-stack, which is particularly good for applications such as cytology, first put your image out of focus on your physical microscope. Here, with the red record button on top, click it, and a timer will start counting down. Now you want to scroll through to the area where it's in focus, past that area where it's in focus, and down to the other side of the tissue where it's out of focus again. Then you can press stop. What you'll get is a frame accurate digital scroll that you can use to observe your samples. Now, sometimes not everything we capture is useful. So for regions all the way to here are useless. You may have the trim options here. So we trim on the left, we trim on the right, then you press the scissor button to apply trim. This will ensure that everything you have is relevant. If you like, you could export this as an AVI. You can take a snapshot of the specific depth, or you can play this like a video player. Everything can be titled and annotated, and once you're done, press done here. So what we have now is a scan with the map, the multi-objective, and a Z-stack, and two annotations. And everything will be libraried on the left here. If you would like to find an area quickly, make sure you title them, and if you just click on the libraried item, it'll jump right to the item. So for example, I click on the Z-stack, it will jump to the Z-stack. If you would like to see it, you can click the play button, or here you can click the enter button, and it will automatically show the area. So that concludes the main functions. You can do as many of these embedded elements as you like. Just be aware that file size does scale with how much you use. So naturally, the more your image, the more files, the bigger the file size is going to be. So once we're finished on the acquisition side, let's talk about how to save these files. The saving operation is very straightforward. It's as simple as saving a Word document. On the left there, I clicked press scan, save scan. And by default, the scans are saved in an SVS format. So here we'll just do test training. One thing that you need to know is there's a flat scan and a folder with the same name. The flat scan is the map, and the folder has all the associated embedded elements, meaning all the annotations, Z-stacks, and multi-objective scans. To open your image, open the flat scan. The thing you have to be careful about is making sure that the image and the folder are always in the same directory, meaning they have to be in the same folder together. Without the folder, you'll only be able to open the map without any embedded elements. But when you're ready, double click and it will take you to the viewer software. The viewer software can allow you to do any annotations after the fact. You may hide the annotations with the I button here. You may lock the annotations with the lock button here. You can do everything that the acquisition software is able to do aside from capturing more images. These can be shared and sent on your local server or through any file sending channels that you have.